All right, everybody, welcome back. It's time for another deep dive, our fourth one.
Come on already.
I know, right? Time flies when you're having fun exploring the frontiers of science and knowledge. And
Complicated stuff.
that's right, complicated stuff. And today, we're going to be diving deep into some seriously mind-bending physics. So get ready.
Buckle up.
Yeah, buckle up. It's going to be a wild ride.
Absolutely.
And to guide us through this quantum jungle, we have, well, I'm not even going to say bona fide expert because that sounds so formal.
Yeah.
But we have a resident quantum enthusiast.
Yeah, I think enthusiast is a good word.
Yeah, who's going to be breaking down all the complicated stuff for us so we can all understand it.
I'll do my best.
All right, so the research we're diving into today centers around a radically new method for entangling light and sound.
Oh, that's a good one.
Right.
Yeah.
And for anyone scratching their heads right now, like, what is entanglement?
Yeah.
What are they talking about? Don't worry, we're going to break it all down.
I'll explain it all.
But first, can you give us the, quantum entanglement for dummies version?
Yeah, so quantum entanglement is, it's this really bizarre...
It's weird.
It's weird, yeah.
Spooky, right.
Yeah, it's like this spooky connection between two particles where you do something to one particle and instantly the other one reacts no matter how far apart they are.
Yeah.
So it's like they're communicating faster than the speed of light, which, as Einstein said, is spooky action at a distance.
Yeah, it's one of those things that makes you question, okay, is our understanding of physics even complete?
Right.
Because this is wild stuff.
It is.
So, but what makes this research so groundbreaking is that we're not just talking about entangling two of the same kind of particle, like two electrons or two photons.
No.
This time, it's light and sound.
Right.
Okay, now those are two very different beasts.
Right, different.
Like one's zipping around at light speed and the other one is, a lot more laid back.
Yeah, much slower.
So how do you even begin to entangle something like that?
Yeah, right. So that's the challenge.
Yeah.
And we typically think of light as these tiny packets of energy called photons,
Right.
and sound as these vibrations traveling as waves. But in the quantum world, we also have something called phonons, which are essentially quantized sound waves.
Okay, so photons for light, phonons for sound.
Exactly.
Got it.
Yeah.
But how do you bridge that gap, right?
Yeah.
I mean, their speeds and energy levels are completely different.
Totally.
It's like trying to, sync up a hummingbird with a sloth. It's like, how do you do that?
Yeah, so that's where this research gets really ingenious.
Okay.
They're proposing to use something called Brillouin scattering as the key to this unlikely entanglement.
Brillouin scattering.
Brillouin scattering. That's
sounds-
a mouthful.
Yeah, it sounds intimidatingly complex.
It is. It's a complex phenomenon, but it's actually simpler than it sounds.
Okay, good.
So imagine shining a light through material,
Okay.
and that light scatters off the sound waves within that material. Okay. That scattering causes a transfer of energy between the light and the sound.
Okay.
So what the researchers are proposing is to use a specially designed waveguide.
So this waveguide, is there a way to visualize that? What is that?
Yeah, so think of it like a tiny tunnel
Yep.
for light and sound.
Got it.
So they're basically amplifying this Brillouin scattering effect.
Okay.
And the idea is that within this waveguide, the photons and phonons will become entangled through this intensified interaction.
So it's like they're creating this tiny controlled environment where light and sound are forced to mingle.
Yeah,
And through that mingling, they develop this spooky connection.
exactly.
This is blowing my mind.
And what's particularly interesting is that this approach has the potential to address one of the biggest headaches in quantum technology: noise.
Noise, the enemy of,
Everything.
pretty much everything, right?
Yeah.
Especially clear signals.
Right.
So why is this type of entanglement potentially better at dealing with noise?
Yeah, so entanglement is notoriously fragile.
Even the tiniest disturbance can disrupt that delicate connection between particles. But this new method, by entangling particles as different as photons and phonons, might create a more robust system.
Okay.
So it's like, imagine building a bridge with multiple diverse supports instead of just relying on one type.
Okay.
It's inherently more stable and less likely to collapse if there's a bit of shaking going on.
Okay. That analogy really clicks.
Good.
Yeah, it's like a more diversified portfolio.
Exactly.
Right, like, don't put all your eggs in one basket.
Exactly.
So, but before we get too carried away with the how, let's step back and talk about the why.
Okay.
Why should we, the non-physicists of the world, care about entangling light and sound? What's the big deal?
So it all boils down to one word.
Potential.
Ooh, I love potential.
This breakthrough could unlock a whole new realm of possibilities for quantum technologies.
Like what? Give me some examples.
So imagine super secure communication networks, computers that can solve problems in seconds that would take our current systems millennia.
Okay, that's pretty good.
And even, dare I say it, the mind-bending concept of quantum teleportation.
Whoa, hold on a second.
Yeah,
Quantum teleportation. That sounds like something straight out of Star Trek.
it does.
Are we talking about beaming things up?
Not quite beaming up,
Okay.
but it's definitely in the realm of the seemingly impossible.
Okay.
It's all about transferring quantum information, the very essence of a particle's state, from one location to another without physically moving the particle itself.
Okay, so the information is teleporting, but not the actual physical matter.
Exactly.
Okay, my mind is officially blown.
Okay.
So, if this research pans out, what kind of real-world applications are we talking about? Where could this entanglement method actually be used?
So the applications are incredibly diverse. We're talking about advancements in fields like quantum computation, where complex calculations could be performed at unimaginable speeds.
Hey.
Quantum storage, where vast amounts of data could be stored in incredibly dense and secure systems.
So like a quantum hard drive the size of a grain of sand holding entire libraries?
Potentially.
That's wild.
Yeah.
What else?
The researchers also highlighted the potential for quantum metrology, which involves making incredibly precise measurements using quantum phenomena.
Quantum metrology, okay.
So imagine sensors capable of detecting the most minute changes in gravity or clocks that are accurate to an almost unbelievable degree.
So that kind of precision could revolutionize everything from, like, navigation
Absolutely.
to astronomy, right?
Yeah.
Okay, crazy.
Yeah.
But, okay, let's not forget about that quantum teleportation you mentioned.
Right.
How does that actually work? Are we really talking about teleporting physical objects?
So, to be clear, we're not talking about teleporting physical objects like in science fiction movies.
Okay, good. I was a little worried there.
Yeah, quantum teleportation is all about transferring the quantum state of a particle to another particle, no matter how far apart they are. Okay? It's like making a perfect copy of a particle's quantum information at a remote location, even though the original particle never physically moved.
That is some seriously mind-bending stuff.
It is. It's pretty wild.
But it's also incredibly exciting to think about the possibilities.
Absolutely.
It feels like we're on the cusp of a technological revolution, all thanks to the weird and wonderful world of quantum mechanics.
It's a very exciting time to be alive and witnessing these scientific breakthroughs.
Absolutely, and who knows what other wonders await us as we continue to explore the quantum realm.
Exactly.
There's so much more to uncover, and I can't wait to see what the future holds for quantum technology.
Me too.
It's going to be wild.
It's going to be amazing.
All right, well, we're going to take a quick break, but when we come back, we're going to delve even deeper into the potential applications and implications of this groundbreaking research, so don't go anywhere.
Stay tuned. It's a journey full of surprises, that's for sure. And speaking of surprises, there's another layer to this research that I find particularly intriguing.
Ugh. Do tell, I love a good twist in the tail.
Well, this new method of entangling light and sound, it operates at higher temperatures than most quantum experiments. And that's a big deal.
Okay. Why is that so important? Does it have something to do with practicality?
Exactly. Most quantum experiments need to happen in super-cooled environments,
Right.
close to absolute zero, which is incredibly difficult and expensive to maintain. But if this technique can work at higher temperatures, it could make quantum technology much more practical and accessible.
So instead of needing these massive specialized labs, we could potentially see quantum devices operating in more everyday settings.
Potentially, yes. It's a step toward bringing quantum technology out of the lab and into the real world, which opens up a whole new set of possibilities.
Now that's something I can get behind: quantum computers in every home, maybe even quantum phones. Okay, maybe I'm getting ahead of myself. but it's exciting to think about.
It is exciting. But let's not get too carried away just yet. There's still a lot of research and development to be done before we see these kinds of widespread applications.
Of course, but it's always inspiring to see scientists pushing the boundaries of what's possible. And this whole idea of entanglement, it reminds me of something we often talk about in the context of personal growth.
Oh, I'm curious to hear your thoughts on this. How do you see entanglement relating to personal growth?
Well, we're all interconnected, right? Our thoughts, our actions, they have a ripple effect on the world around us. It's like we're all entangled in this web of existence.
I like that analogy. And just like in quantum entanglement, where the measurement of one particle instantly affects the other, our actions can have far-reaching consequences that we may not even be aware of.
Exactly. It's a reminder that we're not isolated individuals,
Yeah.
but rather we're all part of something much larger than ourselves. And that interconnectedness, that sense of entanglement, it can be a powerful force for positive change.
Absolutely. By recognizing our interconnectedness, we can start to cultivate a deeper sense of empathy and compassion for others. And that can lead to more harmonious relationships and a more just and equitable world.
Couldn't have said it better myself. But getting back to the research, I want to dive a bit deeper into some of the specific applications that were mentioned. We talked about quantum computing and storage. But what about quantum metrology? How would making incredibly precise measurements using quantum phenomena change things?
Quantum metrology has the potential to revolutionize a wide range of fields. Imagine sensors so sensitive they can detect the tiniest variations in gravitational fields, or clocks so accurate they can measure time with unprecedented precision.
Those are some seriously impressive capabilities. What kind of real-world impact could that have?
Well, for starters, it could revolutionize navigation. Imagine GPS systems that are accurate to within a millimeter, or even better. Imagine navigating without relying on external satellites altogether.
That would be a game changer for everything from self-driving cars to exploring uncharted territories. What about other fields?
Quantum metrology could also have a huge impact on astronomy. We could detect gravitational waves with even greater sensitivity, leading to new discoveries about black holes and the early universe. And in fundamental physics research, ultra-precise clocks could help us test some of the most fundamental theories about the nature of time and space.
So we're not just talking about incremental improvements, but rather a whole new level of precision that could lead to groundbreaking discoveries. That's amazing.
It is truly remarkable. And then there's quantum teleportation. I know we touched on it earlier, but it's such a mind-boggling concept that I think it deserves a bit more attention.
You read my mind. I'm still trying to wrap my head around how you can transfer quantum information without physically moving the particle itself. It feels like magic.
It does, doesn't it? But it's based on the very real principles of quantum mechanics. Let's break it down a bit further. Imagine you have two entangled particles, we'll call them A and B, located in different places. Now you introduce a third particle, particle C, and entangle it with particle A. By making specific measurements on particles A and C, you can essentially transfer the quantum state of particle C onto particle B. Even though they've never interacted directly, it's as if the information encoded in particle C's quantum state has teleported to particle B.
Okay, so it's not the physical particle itself that's moving, but rather the information about its state.
Exactly. And that's what makes quantum teleportation so fascinating and potentially transformative. It opens up the possibility of transmitting information in a completely new way, one that's potentially much faster and more secure than our current methods.
This all sounds incredibly promising, but are there any potential downsides or risks associated with these quantum technologies? Is there anything we should be cautious about as we delve deeper into this realm?
That's a very important question, and one that we should always be asking as we explore new frontiers. One potential concern is the impact on privacy and security. Quantum computers, for example, could potentially break the encryption algorithms that protect our online transactions and personal data.
That's a sobering thought. Are there any safeguards being developed to address this potential threat?
Absolutely. Researchers are already working on new encryption methods that are resistant to quantum attacks. It's an ongoing arms race, but one that we need to take very seriously.
It sounds like we need to be very mindful about how we develop and deploy these quantum technologies, ensuring that they're used responsibly and ethically.
I couldn't agree more. It's essential that we have open and honest discussions about the potential implications of these advancements and work together to create a future where quantum technology benefits all of humanity.
Well said. And on that note, I think it's time to wrap up our exploration of this incredible research. It's been a truly mind-expanding journey into the realm of quantum entanglement and its potential to revolutionize our world.
It really has been fascinating, hasn't it? This whole deep dive into...
I know, right? It's like we've only just
Yeah, scratch the surface.
Scratch the surface of what's possible with this technology.
It feels that way.
It really does. And you know what? And as we were discussing all of this, a thought kept popping into my head.
Oh, yeah.
Like, what if this research on entangling light and sound is just the tip of the iceberg?
I like that.
Right.
Yeah.
What if there are even more mind-blowing applications of quantum entanglement that we haven't even dreamt of yet?
It's certainly possible. Our understanding of the quantum realm is still in its infancy, really.
Right. It's like we're just babies in this world.
Totally.
And I mean, think about it. 100 years ago, could anyone have predicted the internet? Smartphones. All the technology that shapes our lives today.
Not really, no.
Probably not, right?
Uh-uh.
So who's to say what incredible advancements await us as we continue to unravel the mysteries of quantum mechanics?
Right. The possibilities are pretty much endless.
It's both exciting and humbling, to consider the possibilities.
Totally.
It really is.
Yeah.
So, maybe someday we'll be using quantum entanglement to, enhance our consciousness.
Whoa.
Right?
Yeah.
To communicate, telepathically,
That's far out.
or even to travel through time.
Yeah, time travel, that's the holy grail.
Right.
That's what everybody wants.
I mean, who knows, right?
Yes.
It's a future that's full of potential, that's for sure.
Absolutely.
And I, for one, am incredibly excited to see what unfolds.
Me too.
So to our listeners out there, I encourage you to keep exploring,
Yes.
keep questioning,
Stay curious.
and keep diving deep into the fascinating world around us.
Because who knows, maybe one of you listening will be the one to make the next groundbreaking discovery.
Right. It could be you.
Yeah.
That's so cool.
It's an exciting time.
It really is.
Yeah.
All right. Well, that's a wrap for this episode of The Deep Dive.
It's been fun.
Thank you so much for joining us on this incredible journey into the world of quantum entanglement.
Yeah, thanks for having me.
It's always a pleasure to have you on. And to everyone listening, we'll see you next time for another deep dive into the most fascinating and thought-provoking topics out there.
See you next time.
Bye.
Bye.